Hello and welcome everyone. Good morning. Welcome to the collaboration conference on artificial intelligence here in Hybernská. My name is Stepan Vizi. I will be moderating this morning for you. And today we will be, of course, talking about artificial intelligence and its benefits and risks. In this rapidly evolving landscape, AI is poised to revolutionize industries, reshape economies, and redefine the way we live and work. This is what ChatGPT wrote yesterday evening when I asked it to provide me with some interesting introduction for this event. So should we believe it when it's saying this? Is it just boasting, or what will it mean for different sectors and different industries and parts of our economy and of our lives? This is something that we want to discuss today. And we have 6 different inputs prepared for you today regarding different variety of topics and also from different fields. Different examples, hopefully, of how AI can be and will be applied and is applied today already. And we also have one small surprise for you that you will learn about during the coffee break. So there's something for you to look forward to. But before we start, I would like to thank the organizers. That is, of course, Kampus Hybernská, also the Charles University and the Center for Knowledge and Technology Transfer of the Charles University, the German Embassy in Prague, and also the platform Collaborations for the Future, and also AI Days, because this event is actually part of the AI Days that are right now happening, that were full of events in 4 different cities and 4 weeks, and that are ending this weekend. So if you are interested in more content and discussions on AI, there are still some events to visit today and tomorrow. And a few also technical remarks. First, we are also streaming this event, so welcome to everyone who is watching us online. We are happy that you made it at least online. And please note that this event is also recorded and will be available online, so keep that in mind. I think before we can start, I would like to welcome Mr. Tomáš Skopal to give some opening remarks. Tomáš Skopal is the Vice Rector for Information Technology at Charles University. So please, Mr. Skopal, thank you.
Good morning, everybody. I would like to welcome you on behalf of the Rector of Charles University, Professor Králíčková. And I would like to give just a few words how AI affected the life at Charles University, or maybe at universities in general. If we were standing here 1 year ago, okay, the AI was already a topic, but was not targeting the very broad society. It was limited to autonomous vehicles and the AI enthusiasts and computer scientists and so on. But what happened 11 months ago actually started a revolution when generative AI in the incarnation of ChatGPT started to affect everybody. So also the universities were at first in shock because suddenly the students start to use it, and also the teachers and everybody start to use it. And it was a completely new situation because it actually broke the traditional ways of teaching, validating knowledge, testing students, and so on. So the first reaction, of course, as immune system does, was some attempts to ban it and to forbid everything. But this appeared very quickly not to be the way, because you cannot stop the development. So in the first half of the year, of this year, there were very many activities towards setting some guidelines for using ChatGPT and generative AI in general at universities. And we have some guidelines now, we have some best practices and so on. So nowadays it's not in the position of something that is a threat, but more likely it's an opportunity to include it in education. Of course, it brings also the challenges how to include it into education, because it really has a deep impact on not just on testing students, but on the didactics and on the content of the education itself, because the generated content is not just a tool, but it's some kind of object to study, and in very many disciplines, it's not just limited to technical ones, but to all of them. So this was one perspective from the point of universities, at least Charles University. The other is AI in research, which also goes hand in hand with the generative AI, because we now experience more and more that AI is not just limited to computer science and technical programs, and it affects humanities, medicine, very many fields that need to work together in collaboration, really targeting the title of the conference. And we need to now connect all of these stakeholders and the different faculties. We have 17 faculties. It's a real huge community of people and subjects to work together, because we heard for a long time that computer science, oh, that's not my problem because I'm working with linguistics or something. But nowadays this is not true, because AI affects everything. It becomes a standard method for science. I think, in my opinion, it becomes the same importance as a method as mathematics or statistics, but on different level of the technical possibilities. So this is the necessity to deal with. Yes, so for me personally, the AI is something that is not just a buzzword, but of course we use it as a buzzword because we need to quickly talk about AI, not about the actual methods behind that. But still, I think this is valuable debate to talk about it, to discuss the risks, the benefits, because of course there are both sides of the same problem. And I believe that it will become a standard tool in our lives and in the education system, and in turn in the practice and in jobs that of course must reflect this new situation as well. So thank you again, and welcome to this conference, and have a nice day. Thank you.
Thank you very much. Thank you very much, Mr. Skopal, and thank you also for opening the topic of AI in education, because that will also be a topic of one of the inputs further on by students. So it will be a little bit of a different perspective, and I'm very much looking forward to that. But first, maybe Mr. Skopal was mentioning what a breakthrough it is and how relevant it is for everyone and everything, basically, nowadays. So let me ask the audience first, how many of you already use AI in your work or student life, whatever, if you could put your hands up. Okay, so that's, I think, slightly more than a half, yeah. Of course, this is not a representative sample at an AI conference, but yeah, we can see that it's already very relevant for most of us, actually. So now let me please welcome Mr. Tilman Becker, who is the director of the Research and Innovation Center on Advanced Industrial Production at the Czech Institute of Informatics, Robotics and Cybernetics. He's a researcher and an expert in the field of Industry 4.0, and he will be talking about artificial intelligence and its role in industry transformation. So please, the floor is yours. Thank you.
So, good morning, everyone. Let me start by very briefly introducing where I'm coming from. So, RICABE is a new center is applying not just artificial intelligence, but really computer science methods in general for industrial production, for manufacturing in particular. And the new center is a cooperation of the Czech Institute at the Czech Technical University and also the CETEC Institute at the Brno University of Technology, together with German partners. My personal background is as a senior researcher at DFKI in Saarbrücken, which is the German Research Center for Artificial Intelligence. It's funded by the Czech government and by the EU, and we're building up a center to bring these methods into actual industry. So my perspective is specifically on applying these methods in industrial production. But let me start with a few general words about artificial intelligence. These days, artificial intelligence is used synonymously with ChatGPT. And that's true in one direction. ChatGPT is definitely a fantastic product out of decades of AI research, in particular in natural language understanding, computational linguistics, and machine learning, mostly. But not all AI is ChatGPT, not even all AI is generative artificial intelligence in the sense of generating things learned from data sets, images, videos even. So what AI actually is a big debate, philosophical debate even. So a very vague definition would be something like any advanced behavior that's controlled by a computer. It doesn't even have to be a digital computer, although it mostly is. Today what we have from AI are very many different methods, and they can be used as building blocks, as tools in various settings. But they're also always only just building blocks. Something that's called general AI, or sometimes artificial general intelligence, that's on the horizon, maybe on the far horizon, we don't know. If it ever comes, it will come very fast, so be prepared in a way. But that means an autonomous system that is self-aware and that acts with reasoning about itself and its environment, and will think of things like procreating. And that's very dangerous, of course, but that's quite far away in the sense of not offered by anyone and not being researched in a serious way with comparable results as ChatGPT, for example. So that autonomy that would be part of that general artificial intelligence, that is a completely separate aspect. Today, AI is just a tool that's embedded into something. And that something could be a Boston Dynamic robot dog with a gun on top of it, employed by police and made semi-autonomous. And maybe that's a bad idea, but that's a separate story. So, as I said, it's often used synonymously with generative AI, and that means large language models in particular, but also can apply to images, to videos, to audio processing. You might have heard that the Beatles have just released their latest and last song, and the headline says, "By the help of AI." And if you actually read the article, AI was used to remove some noise from the original recordings from John Lennon of 30 years ago. And that was the use of AI, because without that noise, it was actually nice to listen to and not before. Other than that, there's no AI in this, so it's really a Beatles song. Go and buy it. In many applications, these particular versions of AI don't play such a big role, so I'll not be speaking about them any more than this. And one final remark, though, in particular, the large language models, there is an enormous amount of money behind those. So if you look at the spending that the big companies, Google, Microsoft through OpenAI, Meta, the company for Facebook and WhatsApp, and also Apple to some extent, are spending, this is tens of billions of dollars. So what they're doing, they're creating things like GPT. Training of ChatGPT costs around $100 million. That's money that's not available in public research at all. So there's something very wrong there. And the only way that can be fixed is by joining forces. So bringing AI research, for example, all over Europe together in one place will put us in a position to actually compete, because we're currently not. Anyone who's using AI is using one of the free services, or maybe you're paying already, offered by OpenAI. And that's big business. So they're investing heavily and hope for a return on that investment. Okay, so let me say a few general words about AI. So one thing you might have heard is that data is not information, is not knowledge, is not wisdom. And that's exactly what AI is trying to implement, to get from raw data by interpretation to a level where you can call it actual information, to then apply methods like information extraction to use that information and transfer it into something that would be on the knowledge level, so you can actually act upon it automatically or through humans by presenting it in the right way. And if you can derive meta-knowledge, that's really the highest level of representation. If you can understand that certain things appear repeatedly, then maybe you can derive more general rules from this and change your guidelines, for example. And that's what technologies like knowledge representation and knowledge management systems are trying to deal with. And this has been the topic of AI research in the last 60 years. AI is really about understanding of typically digital information by digital processing. So it's physical reactions of robots and other networked devices. That's, of course, one of the applications in industry. It's reactions in the virtual world with chatbots or in the metaverse. It's working on text, for example, summarizations, not just text, but also conversations. The next level would be automatic summaries of meetings, particular video conferences. If you haven't been there, can you get the 2-minute, 5-minute, 10-minute summary automatically? That's within reach. It's about answering questions. That is something that ChatGPT does relatively badly, actually, because it has a lot of information in it, but not in the sense of a database. If you ask it for references, it will hallucinate references. People have tried this publicly, and very humiliating. And it also is, as you can see by playing with DALL-E, for example, or other image networks, connecting linguistic descriptions and images. So here's an example of some of the building blocks. I'm not going to go through them, but just to convey this impression that AI is more than just generative AI. It's building blocks of various provenance and applications. So there's things like transfer of control. What kind of methods do you apply to semi-automated systems to get control back to a human operator? Most prominent example are autonomous driving cars. So far, they're not. You have to be back on the wheel, and you're sitting in front of the wheel. But how does a car in the future signal the driver that within the next 2 or 10 or 30 seconds, they need to be back in control, because the system can predict that the upcoming situation it will not be able to handle. So just one example, and there are many, many building blocks in many areas. The other side of the presentation today is what is the impact of industry. And if you heard the term Industry 4.0, you might have heard this is the 4th industrial revolution. The first one, of course, was mechanizing things at all through in areas like weaving and steel processing. Then the second industrial revolution introduced mass production. Famous example, the conveyor belts at the T model for Ford. And then the third industrial revolution introduced electronics, but not really digital in the sense of complex programming. And that, together with networking, leads us to the 4th industrial revolution, and we're sort of in the middle of it. It's a slow revolution. Officially, it started like 10 or 11 years ago by giving it a real name and having the first applications, but not every factory is completely transformed it right now at all. So this is an ongoing process. The short version of this is everything has a connection to the internet. What do you do with it? That's really the core of the fourth revolution, this networking aspect. And this is, in addition, driven by some socioeconomic aspects like an aging society. We have people who have learned their skills 40 years ago, and they still need to be employed and do useful work. How can you support that? We do have, in general, a lack of skilled workforce. The boomer generation is retiring, and there are fewer younger people. And who is filling these gaps, and do they have the right skills? And often they don't. And there are other things like ever shorter product life cycles, which isn't necessarily a bad thing, because one of the things that's connected to this is product variability, in particular on the production size, then this goal of Industry 4.0 of having batch size 1, meaning every product is completely individual. And that is something in search of a market, but it's also in demand in some areas, and the big question is, how can that be introduced? If you buy a car, you can get it in 1 million combinations, because you can choose that color for the exterior, for the interior, different wheels, etc. But if you go to the car manufacturer and tell them, well, my garage is rather small, can I have the same car but 10 centimeters smaller, please? That is something they can't do yet, and that is definitely something that will be desirable in many instances, but also it must be affordable. So having that kind of advanced production at the same efficiency level as mass production, that is really the advantage that we might be able to reach in Europe, and that might separate production in Europe from production in cheaper labor markets. If you do things in Asia, you can only do it in mass production at a certain level of efficiency, but maybe with AI methods and other computer science methods in industry, that is something that can be done in Europe too. So we could keep production here. And some of these building blocks have obvious applications in some of these areas. Take, for example, the second one, machine learning is one of the modern methods for predictive maintenance. Predictive maintenance is a standard example in industrial production where typically machines are stopped, taken apart to some level. Take airplanes, which have very different levels of maintenance, including an almost complete disassembly. Every 1,000, every 10,000 hours of flight, and if you can collect enough data, you can predict very reliably that this is not necessary yet, because everything's fine. Or you might detect early, well, it's not scheduled yet, but it really should be done right now, before something breaks. And if you have better control of this, in general, you avoid accidents, or you save a lot of money by doing maintenance later. And that's an area that needs data collection. So this was one of the first applications of big data, but is now controlled not by simple statistics methods, but also by machine learning. And that applies to many areas. In the RICAPE Center, we're trying to move these applications into actual production. So transfer with our industrial partners is a big issue. And I'll very briefly show this. These things take time. So this has started in 2016 with the first signature of a memorandum of understanding starting this. And we're in full gear since the beginning, since the end of 2019. This is supposed to be an ongoing endeavor with these four original partners in Prague and in Brno and in Germany. We are adding more partners like the Fraunhofer Institute in Dresden and the University of Ostrava to this, trying to bring this into research and also into industry. Just a big picture of what we have. Do come visit, contact me directly. We're having tours occasionally, so maybe you can hop off on one of those. It's a big laboratory that we call the test bed on 2 floors here in Prague with different kinds of machinery, model production areas where we can test certain implementations before they're moved out into industry, where students can work on those. So master thesis, bachelor theses, and PhDs are working there. We have a similar laboratory in Brno, working with slightly different kinds of machinery, with autonomous, semi-autonomous robots that can navigate the hall by themselves and don't need to be remote controlled. Slightly more elaborate than your vacuum robot, maybe, and definitely more stronger. They can carry like 300 kilograms around, which could be another robot arm on top of it to do things like inspection. But I will close with some examples of what can be achieved. As you've seen in the background of one of the earlier slides, efficiency is always in the background of everything. Enhancing the efficiency of any kind of processes, for example, the big pressing machinery, which is really expensive for heating up, for keeping quality and so on. If that can be scheduled better, that's a big advantage. Integration into the software systems that are set up by the big players. For example, Siemens has this MindSphere cloud-based computing environment. We're working on modules for those. AI methods are good for optimizing planning approaches. So the planning and scheduling systems are used in industry. They're applied at Airbus. We're working closely together with Lego in the Czech Republic. They have very interesting challenges because some of the machinery is well proven, but old, and migrating this and adding sensors to machinery is a real challenge. Energy saving is an obvious result of being more efficient. If you put robots together with a larger picture of what's going on, you can make robots to go slower. The default is that the robot will move from A to B as fast as it can. But if you know what's going on, you can tell it, well, it's not needed. You will need to be there only in 5 seconds, so please go slow, because if the robot goes slower, it uses less energy. And it's very simple to save 10–15% energy by looking at the larger picture and making the moves more efficient. Another technology that's playing a bigger role is 5G. We do have here in Prague one of the first private campus installations. So we're not connecting to the public 5G network. We have our own. We're our own telecom provider in a way. That's in support with T-Mobile Czechia. And that allows wireless communication in a factory floor more efficiently. It's faster in the sense of getting signals somewhere faster with lower latency. It has more bandwidth. And more importantly, it has quality of service guarantees. If we need to send video from a camera to an image processing process on the network somewhere, and where on the network is an interesting question, then our own 5G network, and particularly the 5G part of it, can guarantee that the video stream will never be interrupted. If you do it through Wi-Fi, it's guaranteed that it will be interrupted at some point, but you don't know when. That's an interesting another type of technology that we're working with. And if you look at the mask down there, a real mask, not just a face covering, that was something that was created by 3D printing in the early days of the pandemics and has been printed tens of thousands of times at different places. And that's the kind of knowledge that's available in the laboratory, how to do this, and has been awarded by a number of prizes. And we've published the design plans for free very early on. What are the challenges that we're still working on? One is interoperability. Can you get different machines and people talk together, which would allow a flexible production? Approaches like manufacturing as a service. Can you put together a new manufacturing line by buying services from different manufacturers? Get the assembly of these two parts from this partner, then move them somewhere else, having them to paint it and so on. Is this something that can be more organized, more automated, and therefore allow more flexible production? It's definitely something that the big players have been fighting with in the early days of the pandemics, when containers were stuck in China and not transported, and they didn't have a second source. So if you can automate these things, that's a big help. Keeping the human in the loop is one that most AI systems try to do. So they try to support humans through assistance systems. Some things will be replaced by robots, naturally, heavy lifting and so on. But typically, AI is not there yet, that it can do everything on its own. That would be wonderful. We could all go home and not worry about how things work anymore, but we're far from that. So right now, human intelligence is very important, and one way to enable it better is through assistance systems. One thing that applies to the generative AI systems is data quality and data amounts. GPT and the large language models only work because our texts are completely digitized and available. Copyright will kill some of these systems, and they will need to be rebuilt because they used texts that are available but not legal to use. In other areas, we don't have that kind of highly annotated data. So for production, in particular if it's small batches, we simply don't have the amount of data that's necessary to use the current methods. Maybe the methods show more progress and can be trained quicker. Maybe we can get more artificial data through simulations, but data amounts are definitely a challenge. And security and intellectual property ownership always, of course, is. I already mentioned lot size 1. This has to do with teaching customers that things are available and putting this into new business models. And finally, one application is of AI in particular in production is to avoid defects. In a lot of cases, things are tested only at the very end. And can we not look at every single production step and make sure that it works perfectly all the time by controlling every single step and stop production right there if we see errors happening? Are these things supported by AI? Potentially yes, no surprise here. Let me close with one prediction where you will see AI at work in an area that is not directly related to industry. With the flexibility that you get from things like ChatGPT, I can see that home robotics will make the next big market, because currently you have your vacuum cleaner running around, and we have these robots in the industrial environment and know how clunky and how clumsy they are. But if you can tell them to be more flexible and to breathe wrong some of the time, but to be safe also, those are components that are available, and the current learning methods will make it feasible to employ robots at home to do your dishes, to put things on the table, back again, into the dishwasher, out again, into the cupboard, and so on. That might be the next big application of AI that you will actually see and be able to use. And remember, these things then don't think by themselves. They're just tools with different components playing together, and you should always be in control. There should be a big red button on top of it. In industry, there always is. And maybe that's a good lesson. So thank you for your attention, and I'll be happy to take questions if we have time for that. I'm not sure.
Yeah, thank you very much. Unfortunately, I think I have a lot of questions. The audience, I'm sure you also have a lot of questions. We are kind of running out of time. But the good news is there is a discussion at the end. So if you have questions, please take note of them, and there will be space at the end of today's event to ask them and to discuss them. So thank you, Mr. Tilbanbecker. And now let me please welcome Judith Knoblach, who is a research assistant at the Cognitive Systems Group at the University of Bamberg. She is also part of a project that is supporting local small and medium businesses in the digital transformation, and she will be talking about artificial intelligence in industry and in medicine. So please, the floor is yours.
Yeah, thank you for the kind introduction. I'm very happy to be here today and to get the chance to talk about the research of my group Cognitive Systems at the University of Bamberg. The Bamberg Center of Artificial Intelligence is a research center for AI at the University of Bamberg with 9 professorships exclusively researching about AI, and additionally 9 professorships of computer science and business informatics with strong relations to AI. Artificial intelligence and machine learning have been a central aspect at the faculty since 2004. And the focus is on the development of comprehensible, interactive, transparent, robust, and intelligent technologies. The center cooperates a lot with the humanities and is specialized in AI and ethics, AI and health, and AI and education. As already mentioned, I'm working in the Cognitive Systems group with Professor Dr. Ute Schmid, who is the head of our group. We are establishing an SMEs AI center in order to support the application of AI methods in industry and to give people working in that field the chance to gather experience with AI. Our aim is to demonstrate the opportunities of intelligent and sustainable production. Again, our focus is not only on the application of machine learning methods, but also on the use of explainable and interactive approaches. AI algorithms do not require explicitly specified problems as standard algorithms do. These types of not explicitly specified problems often occur in intelligent supply chain, predictive maintenance, or quality assurance. Machine learning methods can be helpful here because they learn the specific requirements of a use case from the data. But these approaches have one big limitation. They are so-called black boxes. So that is, we do not know how they come to their conclusion. What we need here are explainable methods to make the decision of the machine learning model transparent. Additionally, in order to guarantee the robustness of the model, we combine it with symbolic methods, which results in so-called hybrid approaches. And the explainable AI and hybrid approaches ensure a trustworthy use of AI. The figure on the right is from the European Commission's ethical guidelines for trustworthy AI. So as you can see, the subject is already on the agenda of EU politics. In our SMEs AI Center, it is our aim to support regional companies in digital transformation and in the application of AI-supported manufacturing processes. We are going to provide the opportunity to test on concrete applications and train employees to implement trustworthy AI methods. Yeah, we have been doing a lot of planning to achieve this goal. We are going to exhibit prototypes in manufacturing, digital twins, and sensor technologies for process monitoring, predictive maintenance, and quality assurance. There will be also the chance to witness and explore human-robot collaboration during assembly. And we are going to implement transparent and corrective machine learning methods developed in our research institute. We are also going to support SMEs in requirement analysis, and we are also going to establish the regional AI dialogue and networking. So now I am going to show an example of a potential use case you might experience in our SMEs AI Center. A metal part with potential casting defects such as blowholes, burrs, or shrinkage defects is first classified by a deep learning model. And to explain the decision boundary of the model, the similar images from the training data are retrieved, and either they belong to the predicted class, then it's a near hit, or they belong to the counter class, then it's a near miss. If a domain expert disagrees with the decision of the or the decision boundary of the model, they can give feedback and thus improve the performance of the model. Yeah, to conclude the section of AI in industry, I would like to emphasize the benefits of applying AI methods in industry. So resources can be efficiently used. Manual, time-consuming processes will be avoided. Since ethical considerations are becoming more and more important for consumers, sustainability has become a core business of companies nowadays. And also companies can save costs through the efficient use of energy, the prevention of waste, and the recycling of materials. And after applying AI methods, companies are able to provide sustainable and intelligent manufacturing processes. AI methods can also be applied in medicine. Deep learning methods are promising of image analysis, for example, in pathology. And for the analysis of images, a special type of neural network is used, a so-called convolutional neural network, short CNN. And a CNN is particularly interesting since it finds relevant features on its own, so lifting the burden of feature engineering from the shoulders of the developers. But CNNs are black boxes, so we encounter the same problem as already mentioned earlier. We do not know how the model comes to its conclusion. So this raises questions such as, should we trust a black box? What about the legal aspect and accountability? We have a right to explanation and want to understand the decision of the system. So at least at the stage of development, but also for patients who want to know the reason for their diagnosis. Yeah, so to overcome the issue, again, the application of AI, explainable AI methods, and also the model adaptations by humans are possible solutions. For tissue classification, we have applied a highlighting method which visualizes what the CNN abstracted in each layer. So these visualizations can be interpreted by a medical profession. So which pixel in the input image contribute to the decision, and do the involved pixel relate to the clinical expert's knowledge and expectations. And to facilitate the pathologist's visual evaluation task, we have provided a user interface. So you can see it here on the right. Here the medical expert can select the layer and also select a specific model for the classification task. Another tool we have developed for explainable tissue classification allows a medical expert to ask for verbal explanations and to give feedback to the system. Image samples of digital pathology might look completely different even if they are diagnosed in a similar way. Diagnosis may be based on complex compositions such as spatial constellations. For example, a tumor tissue touches a muscle tissue and an adipose tissue, but not a connective tissue. And yeah, we used the tool to evaluate whether the tissue classification preserve the spatial constellations that are relevant based on the PT scheme. The PT scheme indicates the severity of the tumor. For example, if a tumor touches fat, it is quite complex and is labeled as PT3. And a medical expert can mark the produced explanation and define necessary adaptations. For example, which learned facts are wrong and which are missing. And then the underlying model adapts itself based on these user-defined constraints. And this way, falsely classified samples can be identified, and expert knowledge is included in the process. There are still open challenges in explainable AI, especially with respect to evaluation. Which explanation methods are representative to what the neural network has learned? Which explanation methods can be understood by a human user? And both aspects will be important in the future for the future success of machine learning. Yeah, recently we published a paper in the Data Mining and Knowledge Discovery journal, and the paper contains a taxonomy of important concepts and lists methods from the field of explainable AI. It was written for researchers and also for practitioners. It gives an overview and also an entry point if you want to know more about the field. Yeah, at the end of my presentation, I would like to point out that we are active member of AI communities such as Taylor and Claire. And through Taylor, we found a fruitful collaboration with our Czech colleague. I'm probably pronouncing it wrong, sorry for that, Tomáš Klíger. And yeah, we are happy about new collaborations. If you have further questions about our research, my group leader, Professor Dr. Ute Schmid, is the right person. And if you want to know more about AI in medicine, my colleague Bettina Finzel is the expert. And if you want to get more information about the SME's AI Center, you can contact me. Yeah. Thank you very much for your attention.
Okay, thank you very much.
Thank you. I think, again, if possible, please, we will save the questions for the debate, which we will also participate in. So thank you very much to Judith Knoblach. And now I would like to welcome Anna Bučinska and Adam Ragač from the Smíchov Secondary School, who are students at Smíchovská Secondary School of Technology. They are a member of the AI team. They aim to modernize IT education, and they are also organizing events, educating teachers and students on AI, both ethical and technical. So please, the floor is yours.
Thank you very much for introduction. And we are going to talk about AI in schools, in education, more from our perspective, how we use it as a students or as a teachers. I'm going to describe the view of the student. We use tools daily to basically learn new things without a teacher or to even do our schedule. As we talked already about the ChatGPT, we use it to learn about new things when we don't understand them at school. And so, as well as, for example, photomath in mathematics, we can use it to get into a topic, or our teachers use it for us to get the lesson more colorful and fun for us, and so we memorize it for a longer time or get a better knowledge. We also use it for our projects, like a Copilot from Microsoft. For me, as a programmer, I use it a lot because it generates boilerplate code. You can use it as a tool pretty well, but we have to always consider ethical thing and also a precision of the AI, because not always it is right for these multi-purpose generative AIs as ChatGPT or the Copilot. They are not created to be 100% right or even 90% right. So we have to always include our intelligence, our knowledge to correct the AI, or even redo it ourselves. So it's pretty great for us to generate like annotations or these general tasks, but not really for the creativity. So we do the boilerplate with it and then have to use our creativity for it. That's for the students. And we can move on to the teachers.
And I will be talking from the teacher's perspective, even though I'm still a student and I am currently in the second year. But last year I spent probably half of the year teaching at elementary school, because in Czech Republic the IT education on elementary schools is not so great. Kids mainly learn how to type in a Word and how to make presentation, which is quite sad because the IT world is much wider and much bigger. So I was there to empower the teacher, because the teacher was just learning from the scripts that they were given, and they also did not know anything about it. So I was there to help implement modern features into the lessons. And for example, I did some little robotics with the kids. They were 5th graders, so they were not big. They were 10 years old. So I had to think about something simple, but still something that would be attractive for them. Because, as you know, kids lose attention quickly, so does adults. But kids don't hide it, or at their age, then they probably don't know how. Like us, we just like stare somewhere and pretend that we are paying attention, but in real life we're thinking like, oh, next 5 minutes, coffee? Yeah. So, sorry, thank you. But the AI has quite transformed the education system, because most teachers or even schools relied on essays written by students. For example, in the finishing years of their studies, they wrote a big essay or work on what they were studying about and what they learned. But now that AI can generate text quite good. It's not perfect. Like in the Czech, it's rocky, but in English it is quite good. So if you're writing in English, it can easily generate essay for you, and then the teachers would be like, all right, so write about the 3 years and what you learned here. So then the student was like, write me essay about what was I studying? Oh, about English. And then the generative AI just wrote an essay. The student was like, yeah, that's right, all right, good. And he sent it to the teacher. And then the point of the essay was like totally missed, because the student did not do any work on it. And we need to think about how we can use AI in education instead of banning it, because AI is not going anywhere. It will stay with us. So we need to learn how to use it. It's a tool just like calculator. If you search some old articles when calculators came out, the mathematical teachers were protesting about banning it and were totally against using it. But to be honest, today, how many of you really calculates everything in your head? Probably not much. Me neither. So AI is a great tool, but we need to know how to use it properly, because it can also be damaging tool as anything else as powerful. So it is extremely important when we're using AI, even on students, to empower them for critical thinking. Like, for example, if we give them some homework to use AI with, we need to also give them a bullet point where is check at least 2 other sources that information is right and confirm it, because AI makes mistakes, and even if you correct it, there are some people who like to correct the AI wrongly and give it wrong information, and the AI does not check it and just gives it to other people. So we need to double check it every time. And also it is extremely powerful in the aspect of people with disabilities. For example, someone with hearing problems, they can use AI to help them visualize what they are learning currently. And also, for example, for foreign students, there are AI tools that translates the text in real time, which is fast. So the students does not have to worry about not knowing where the rest of their class is, and they can just continue learning with their AI translator. And also, I believe everyone was in school, and you definitely remember someone who was on top of the class and did not do any work. They were just smart, and they came home, they were like playing video games, they came to school, they wrote the test, and A+. But some students does not have that luck, and they actually had to study at home. And some lessons for them were very difficult because they just didn't have the genetic predispositions for that subject. And AI can help by generating multiple versions so that the talented students won't be bored and will have something to do. But the students who are not so gifted can also learn and won't feel like, I'm so dumb, I don't belong here, because a lot of kids in schools, they are demotivated because they cannot do something, but the teacher should help them to empower it. And also in real life, when you are not good at something, you will probably go to some field where you are good at it. For example, we are both at technological schools, so we probably won't go to some humanities schools. I was studying humanities gymnasium, gymnasium, but I realized that languages were not my strongest part, but most importantly, I wasn't enjoying learning them. And I would much rather learn about IT and other stuff. So I came to a different school where languages, we still have them because you need to have some standard, but it's not as much as that. And also when AI broke out, a lot of schools were giving their own how to use AI and other things. But the Minister of Education in Czech Republic was quite late, and our school was the one who gave him the basic materials from which he ended up, or his team, not probably him, from where they ended up writing the whole curriculum, how to use AI in education. That was actually from our school, and I was working on it personally. And when we were there to present it to him, it was like, there were like maybe other 15 to 20 professors of other schools and colleges, and they were like reading it, and they turned to the minister and they were like, "Oh, this is really good, you did very well." And then they like scrolled through and they read that on the bottom it was actually a product of a secondary school. So we were quite happy that they liked it. It had a lot of positive feedback, which was empowering for us to continue doing what we were doing. But also the minister maybe got scared, I don't know, because 2 hours afterwards he left his position. And now we have a new Minister of Education. That's just a joke, he probably had other reasons. But we like to joke about that because it was very funny, because he did not say anything about leaving on that meeting. And 2 hours later, we received a call, like if we knew anything about it. So that was actually quite funny. Thank you.
Okay, thank you. Thank you very much. I would like to ask you to stay just for one question, maybe, because you won't have the opportunity to answer in the discussion later on. So thanks for the really interesting presentation, and sorry for the technical problems with the presentation, but maybe we can send it at least to the participant afterwards. But I was wondering, because in the public debate we often hear about the Czech education system, you know, that it's maybe kind of old-fashioned, it's focusing still on memorizing a lot of facts and so on. But now with AI, maybe like the schools will be actually pushed to transform, because students will be using AI anyway. There's nothing you can do about it. So you have to somehow reflect that in the education. What do you think about that?
I think that the schools who still empower memorizing facts will probably ban AI, because they're not anything near to moving forward. They're very conservative and they're happy as it is. And it was like 20 years ago and it will be like this 20 years afterwards. But the schools that are trying to incorporate modern technology, I don't think that they like rely on memorizing facts. So the schools that are conservative will have this problem, and maybe it will show that less students will come to their school because they don't want to learn in history, and they really won't be prepared for anything.
Okay. And when you talk to teachers, like generally, how open are they to AI? How much understanding do they already have, like what it means for education?
Well, it's slowly moving, but at least at our school, they are really open to it. They want to educate about it, want workshops and good practice, because they know that they will need that. That the students are looking for the usage of the AI and will implement it in their studying or even work. So they are really open.
I will also add that on our school we have like probably 60 teachers who are absolvents of our school, and no, there are not. Usually there is not more than 10 years age gap. So they're really open to modern technology, and we are really thankful to have them because they usually have business in the industry, and then they're teaching us about it. So it's much better to learn from someone who actually have practice in it than someone who just knows the theory.
Okay, thank you very much. So thank you. That was Anna Bučinska and Adam Ragač. We are now approaching the first coffee break. There will be a second one later on, but now we'll take 20 minutes for the break. So we'll meet here at 11:05, and you can find some refreshments at the end of the hall. But before you go there, I promised you a little surprise. So if you turn right at the entrance, there's a music artist or sound artist Ruchi, who also has a small experiment on AI music. So you can try it out. It takes just a minute. So yeah, have fun, and we'll meet here in 20 minutes. Welcome back, everyone. Hope you enjoyed the coffee break and also the small musical experiment. We are now back for the 3 final inputs of today's conference. Afterwards, we'll have a debate. And now, please let me welcome Mr. Jan Macek from Mama AI, who is a co-CEO and co-founder of Mama AI, also the interim CEO of Cheese, and he has a background in artificial intelligence and machine learning since the early 2000s already. And he will be speaking about artificial intelligence in biochemistry and the case study from Czechia. So please welcome to the stage.
Good. Okay. So good morning, everyone. Thanks for coming. Yeah. So I will talk about a particular project that we developed for kind of biochemistry in a partnership between Mama AI and INI Prague, which technically is a part of IOCB in Prague. And basically, Mama AI is a team of AI experts. We originated as a kind of spin-off, although technically it's not a spin-off, but like a team that spun out from IBM. We originally worked for IBM Research. Then we were part of IBM Watson, and our focus was mainly speech recognition, natural language processing, which then translates to machine learning and kind of AI techniques in many shapes and forms. And we joined forces with IOCB, who are the experts in biochemistry and in drug development. And the Cheese as a tool, as a spin-off, is a result of this collaboration. Goal or the aim of Cheese is to provide very fast search in these huge molecular spaces, which count really billions or trillions of molecules, and kind of make different approaches to the molecular space exploration possible. So really, the current problem that the drug developers or biochemists face is really exploring the huge spaces of molecules. And you can imagine that searching through trillions of molecules and looking for similar molecules is really time-consuming or computationally prohibitive unless you have the right representation of the space. And that's where we used our kind of know-how or our approach, where we are able to represent the molecular space in a way that allows for quick searches. So instead of comparing each molecule one-to-one and basically having the quadratic complexity of the computation, we are able to use the representation of the space and basically take the molecule we search by, take a neighborhood in the kind of space that represents the molecule or the molecule surrounding, and retrieve like thousands or tens of thousands, or it's really unlimited, like how many molecules we retrieve from the space, and provide to the chemist for his kind of evaluation or further steps. What's also important that this representation that we kind of managed to train with AI allows for very fast prediction of molecular properties. So there are like typical properties for molecules that are important for drug development or for biomedical chemists. So these are like the so-called ANME properties, which really look for is the molecule toxic, or is it soluble in fat, and other properties that are kind of crucial for evaluation whether a molecule has a chance to kind of go through kind of the human body in the right way, arrive at the right spot, and be efficient drug. We also kind of look at the problem from kind of practical perspective. So you can imagine that the pharma companies are very careful what data they kind of keep for themselves. They keep them very proprietary or patented, and what data are public. So we provide the possibility to take our solution, run it on their premises, and keep the data safe so they don't travel anywhere around the world, around the internet, and they get the results they need. Also, that's kind of pointing to the fourth bullet. We allow many variable deployment options for the tool, and it's basically it runs on our cloud. It's possible to run at the customer, and we are very flexible how the tool is delivered. The cheese is the solution to the problems that we listed here, and it's already running and available to the public. So if you would be interested yourself, just go visit the Cheese the Mama AI, and you can see the tool for yourself. So when I just go quickly to the kind of screenshot of the tool. The idea was, can we provide a user interface that's kind of natural and maybe mimics some of the tools that are already available on the internet? So clearly we got inspiration from Google image search. The user only inserts or puts in the molecular description, and the search immediately gives results that really provide similar molecules with the property predictions, and it's really fast. Also, the user interface allows for quick exploration of the molecular space. As the tool is very fast, it allows for kind of sitting at the desk, sitting at the computer, and making several searches in a sequence. In the past, the chemists usually put in the search query, went for a coffee, and came back and looked for and checked the results. Now they can do this kind of online or live while sitting at the desk. We already got some interesting or very nice feedback from our users and customers. And obviously, as we promised, the search is fast, and the users are valuing it. And they are often surprised how fast the search can get. And also the feedback we get, also this is something the chemists need, and we see clear value in the tool. Yeah, the property prediction, that's also one of the key properties of the tool. So we originally were focusing on the search and navigating the huge molecular spaces, but the property predictions proved to be also very important to our customers. And yeah, at the BioBoston conference in June this year, I got this interesting feedback when I was talking to a person at a stand, showing him our tool, and he says, "Oh, so we developed something very similar, but I like your tool better." Yeah. So once again, so we have the cheese running publicly. It's free for everyone. There is the UI that you can use for like quick checks. There is API that allows you to integrate the tool with your pipeline, if you have one, and then we are kind of exploring like the monetization model, but at the moment the goal is to provide on-prem solution as a paid version. We already have many kind of users and customers, or it's mainly users at this point. I think IOCB, that's obvious one because that's our partner. We have a very good relationship with ChemSpace, which is a Ukrainian company that's considering using cheese as their kind of search engine. ChemSpace is a kind of e-shop for chemists, so to say. So you come there, you find your molecule, order it, and you get it in a, I don't know, week or month, depending on how complex it is to get the molecule. And they are kind of discussing with us whether we can make cheese part of their solution. We are in talks with MSD, really validating our roadmap and checking whether they would be our customers. And with AbbVie, which is another big pharma, we are kind of demo or like testing starting in the next couple of weeks. So we are preparing the solution for them. It should be running with them in a few weeks. And finally, Professor Andrea Bancale, who is from the University of Chemical Technology here in Prague. He was our kind of first sponsor user, or one of the first sponsor users, and he is kind of great source of feedback and hints and kind of making the tool practical for other users. Yeah, I wonder. Yeah, so I mentioned a little bit the business model that we foresee. So currently the tool is running on public cloud. We are kind of validating the traffic and validating the usability for the users and contemplating whether we should keep it free and make the money by on-premises deployments, or whether the traffic is so high and it makes sense to kind of make it paid for some of the users. The on-premises deployment, that's kind of obvious. I mentioned it already. And also what's open to us is providing molecular search services for kind of maybe smaller teams that don't have capacity to do this themselves. Yeah, some market overview. The market is obviously huge. As you can imagine, like pharmaceutical industry is really large, and really basing the total addressable market on the number of researchers and on the number of companies, big pharma, mid pharma, and small pharma. I think we arrived at these total addressable market sizes, and it really makes sense to address this market with our tool. And given the feedback, it's really promising. And kind of the long-term revenue stream that we see is getting royalties from drugs that are developed using our tool, with kind of being paid with the future revenue. So the idea is to provide the tool for free or with some discount for teams who are willing to take part of the future revenue as a payment for the service. So there is quite ambitious roadmap. So currently the tool is able to search by similarity in these spaces and predict the properties of the molecules, but it works on the kind of enumerative databases. What's important and what databases are more interesting to the chemists are the so-called combinatorial databases, and we have a kind of prototype running already for these combinatorial databases, and it's a huge step for the tool because it enables to encode much larger spaces, and we still keep the efficiency in the search and provide the value for the customers. We are improving the visualization kind of capabilities of the tool, because there are like many use cases that are kind of sprouting from the representation of the molecular space. So we are extending that. And then, yeah, I should say winter 2024 instead of 2023. So we are looking into the binding pocket similarity, really comparing the sites where the drugs are kind of targeted at. This is useful for example, side effect identification of the drugs. So that's one use case that we are focusing at. And then finally, we want to arrive at a target-specific search in the next 6 months. Yeah, maybe I can skip the competitive landscape and maybe talk somewhat about the team. Yeah, it's kind of the original kind of AI backbone of the project that provides the important know-how. And I will stop with that here. So thanks for your attention, and yeah, thanks.
Okay, thank you very much. As with the previous speakers, I would save the questions for the final debate, if that's okay. And so thank you very much to Jan Macek. And at this point, I would like to make one small note. If you saw an early version of the program, maybe you noticed that we were also supposed to have a representative of another startup of CropX from Israel, Mr. Yoni Roter, but understandably he couldn't make it today. So of course we are very sorry to hear that, but I think we all understand that it's very difficult. Instead, I would like to welcome Mr. Matouš Kostlivý from Czech Invest, who is the director of the AI Hub and is also is working on startup support and technology incubation, and will be talking about startup support in the Czech Republic. So please, the floor is yours. Thank you.
Thank you very much for being here, and I'm glad to be here as a replacement of the presentation that we couldn't see, but I hope this will be as inspiring as the presentation that you were originally supposed to see. I'm Matouš Kostlivý from Czech Invest, and I'm about to introduce you what Czech Invest does for AI, for support of AI startups and so forth. We are Czech Invest, we are under the Ministry of Industry and Trade. We are a government agency to support innovation and ecosystem, and to support startups and as well foreign direct investments. Therefore, those big multinational companies. We have multiple tools for that. For those big guys, like the big brands that were coming here over the last 30 years, we have financial incentives to motivate them to enter and stay and be happy and grow with their services and activities within the Czech Republic. For startups, we have multiple programs. The most inspiring one and the most ambitious one is technology incubation that is running since last year, where we support startups in the Czech Republic. It's a program that will run for upcoming years, so definitely we will see more startups coming. I have some examples in the presentation, and we will get to that in a very short time. Czech Invest was established in 1992, and at the beginning it was really focused at those to attract foreign direct investment, to attract those big companies. Originally they were coming especially in the manufacturing segment, simply because there was cheap labor force, and still the potential to growth in Europe was in the Czech Republic quite high. So that's how the support for innovation started here. And then in around 2011, our colleague could see how a lot of startups were coming to Silicon Valley. We have as well foreign offices. One of the offices is in US, in Silicon Valley. And so our colleague could see that many agencies such as Czech Invest were bringing Czech not Czech, but European startups to there, and the startups could grow and approach with the local ecosystem, and the ecosystem in Silicon Valley was huge. So it had a huge effect and impact on those startups. That's how it happened that we got this information. This is something that would make sense to do as well for Czech Republic, for Czech startups, for Czech companies. Therefore, we started and launched a project that was called Czech Accelerator. It's over here. It was supposed to help Czech companies to go to the incubators. We had some pre-arranged kind of partnerships with incubators in Silicon Valley, in New York, in Singapore, for those that wanted to go to Asia, and so on. And a lot of companies utilize that, and we could see that it is actually something that's working. So we started to think about other programs that could help startups as such. And so Czech Demo and Czech Match and Czech Starter started to pop in, simply because we could see that this is support that helps startups to go to incubators, but what about if they want to some foreign conference and so on? And this is how it started to grow. At the moment, we have under preparation new project that is called, or will be called, will be rather focused at internationalization project. So it will pretty much, it is a project that will have all these together, and it will help Czech startups to go global, to go abroad, to find this partnership in local incubators abroad, and be more active in this area. Since last year, we have Technology Incubation Project. I am part of this Technology Incubation Project. It is pretty much the most ambitious project as of now in the Czech Republic for startup support. And I will get to that project as well later in the presentation. We don't run just that. We as well launched a couple of years back czechstartups.org. We try to put all the information that are relevant for startups on one place. There is information about local venture capital funds, for example. There is information about events. We try to put all this information on this website. We run as well, for example, in partnership with ESA, European Space Agency, ESA Business Incubation Center. Actually, Czech Invest is part of this network. Actually, we have a support for European startups that would like to utilize space technologies in real-life products, and that was pretty much what this project from European Space Agency is about. They wanted to help to commercialize and transfer the technologies from space, be it data that are there from satellites, or be it the materials that are used somewhere in the space, in some real technologies. Therefore, we have a lot of startups that are focused on utilizing the data from space, or they are making bicycles from materials that were light and still good for bikes, so and so on and so forth. And this is actually how Czech Invest started to look what could be done with some conceptual support, and that's where we got the biggest inspiration for technology incubation. Pretty much it was this practical experience from ESA. We have this project since 2014 or 15, and it's running for 8 years. And last but not least, we have as well, we try to work with the entire ecosystem. We have Investment Academy for startups. In Investment Academy, we have like 5 workshops with partners from venture capital funds, from lawyers, and that help these startups to pretty much get ready for negotiations with venture capital investments, or being prepared for hiring technical employees, and so on and so forth. There is workshop run by lawyers that is about to prepare them for what's about to come, and so on. And this is what we do. We do similar things as well for angel investors. We call it Business Academy, where we partnered with venture capital funds again that try to share their best practice to the potential future investors in the field. Therefore, we are educating the new wave of angel investors. So that's what Czech Invest does to startups, and I am getting to technology incubation because it's a project that supports startups with finances up to 5 million Czech crowns for 40 years. But what is very unique in that is that we gather the ideas already at the stage before the startups are even funded. We have on our website something that is called pre-incubation. Anybody with a startup idea can let us know about his idea. And we have trained colleagues in regions that get in touch with the startupist and guide him through the process in order to basically become the founder of the startup. So he needs to fill the business plan, he has to fill an incubation plan, therefore let us know what the support should be utilized for. And in the business plan he needs to find out who is his competition, home and abroad, what is strength in the team, what is his technology advancements, and put it all on paper, and with that he can apply, but he needs to as well establish ICHO, therefore a legal entity, and this is all that he gets as a support in this pre-incubation phase. We gathered in 1 year over 1,000 startup ideas through this technology incubation, pre-incubation program, and we now can work with that. For example, now as this event organized as a part of prg.ai, the AI Days, Czech Invest is co-organizing that with prg.ai and prg.ai, and actually we as well launched our own AI startup pitch contests in each of the cities that were part of that: Brno, Ostrava, Plzeň, and Prague. We gathered over 150 attendees from the startups during this 1 month, and pretty much we utilized as well the pre-incubation database that we gathered, as I mentioned, throughout the 1 year. Out of 1,000 startups, around 250 were actually related to artificial intelligence or classified themselves as artificial intelligence startup. So quite a remarkable number, something to work with, something we are keen to have, and that's what we do. It's not only about the money that we give to startups, we try to support them with their growth as well, with the networking. We try to organize events such as the pitch contest where they can share or try their pitch, or they can kind of get introduced to the venture capital investors and so on, because I believe that if venture capital investor invest into startups that we supported at the first place, it means that these money were well spent, and it is a state money, as I mentioned. This is not you. This is money that Czech Republic through Czech Invest is putting and pushing to innovation, AI, and startups as such. The support is for startups, therefore the companies should not be older than 5 years and meet all the requirements. I will not get into too much detail. At the moment, supported areas are mobility, ecotech, creative industries, and artificial intelligence. Artificial intelligence is the most seeked, actually, one. Now we raised as well the Space Hub, which is related to the European Space Agency that I showed before. We are running as well Advanced Tech and Materials Hub. Actually, there we cooperate with CERN in Switzerland quite heavily, and now we are as well in discussion about Tech for Life Hub. It was actually launched as well, so startups from the field of healthcare, for example, or cybersecurity, they would fall into this area, and they will be able to apply since next call that will come this year, actually. Next 2 months it should be launched. So that's about it. Just some numbers. This is the first call that we got in technology incubation. As you can see, regionally divided. It's heavily focused on Prague and Brno, South Moravian region. The reason for that, and it's because most of the startups come from there. Most of the universities, technical universities, are there. The biggest number of technical skills and talent are in Prague and Brno. 80% of Czech AI scene is in Prague or Brno. I'm glad actually that we have some potential future next stars. I would like to mention, for example, Plzeň. They have really good university. They are really good in natural language processing technologies. Now there were AI awards just 2 days ago. Team from Plzeň won an award in their. Actually, Mama AI, the speaker who was here before, is actually one of the startups that is supported by technology incubation and was as well one of the nominees in the AI awards and so on. So a lot is happening in the Czech Republic in AI. I would just to see the numbers. The biggest number of startups registered and classified as AI, as I mentioned. In the first call, we got 39 applications. In the second call, we got actually in AI only 69 applications out of 196 applicants, which was quite a remarkable number. 55 startups will be supported in the call that is just now about to be announced. Sorry for the Czech number, for the Czech, but I took these statistics and I had no time to transfer them into English. These are the months. Just to show you when the startups kind of registered to the technology incubation and how the numbers kind of depend on when the call was raised, because in here you can see this is the number of startups that was registered to technology incubation. Actually, we launched this this first call around here, so a lot of startups started to apply, and then the second wave came when the second call was about to be released in June. It was over, so there we were evaluating the next wave of the startups. We can see that a lot of startups are really focused and try to let us know about them, simply because there is this support about to be released. And one of the interesting things as well that we can see in the statistics, I don't have it here, a lot of startups are actually funded as well before our kind of call is to technology incubation is about to be announced. So we can see direct impact, and there kind of technology incubation that is here to support those innovators to start their ideas. Often it's students at universities or somebody working in a corporate who simply would like to push his startup forward, but he doesn't know how or when, or simply has no this motivation to push it forward because he has a nice place in a company and it means to sacrifice something, and this is a motivation for him to start the idea. I mentioned the Investment Academy. I mentioned as well the checkstartups.org. You can take a look at it. I will not, because I'm a bit talking too much, I guess, in my time. Yeah, this is, for example, the Investment Academy that we organized just recently. This is the list of partners that we had in this Investment Academy that were kind of giving advices and support with their ideas and training to the startups that applied. We have some venture capital investment funds, but we cooperate, for example, with British Embassy, which provided us with a space where we could kind of host these events and so on. So we try to involve a lot within the ecosystem. We are really in the center of that, and that's what we do. We as well started to work a bit more with the data. I used to work at Czech Invest since 2013, then I left for some other placement for 5 years, and I came back in around 2 years ago. What I could see that was the biggest difference was how Czech Invest started to work with the data and how they started to as well put the data available online. So if you take a look at the Czech website, then you can see as well statistics yourself, and you can play with it. You can try to see a lot of data that are there available for public about Czech startups, about supported startups, about startups that got venture capital investments, for example. We cooperate with Czech founders on that, and you can take a look yourself. Few pictures from our events that we have. For example, this is Creative Business Cup that has some regional kind of rounds, and Czech Invest is organizing the regional round for the Czech Republic, and then there is one world final it was in Denmark. This is, for example, Startup Nemesis that won this award, and so on. When we talk about AI, I put here these pictures. These are actually pictures from the AI days from the AI just recently. Plzeň, it was like 2 weeks ago. We had this pitch over there. This is actually from 2 days ago. It was in Wednesday. So we had an event in Prague. There was around 80 people, and we had 21 startups presenting their pitch. We had to actually deal with it quite a lot because the interest was bigger than our spaces, so we were changing it. There was a panel discussion and startups were presenting and so on. This is the same event in Brno and so on. So this is what we do for startups. Czech Republic is in a good way supporting especially startups at the very beginning. I'm glad that AI is one of the supported areas. And just briefly, these are the startups from artificial intelligence that we support. Mama AI is here as well. Yeah, if you would like to have more information about what we do or what kind of startups do we have, please just ask. I will gladly share more information or share contacts or get you in touch with them if you would like to know. We are about to just close the last call in upcoming days and announce the next wave of startups publicly, and then we should have, now we have like 11 of them, soon we should have around 30, so that will be one way how we can kind of work with the ecosystem. This is what we do. I am Matouš Koslivý from Czech Invest. I am now director of AI Hub, and that's what we do. Thank you very much.
Thank you. Okay, thank you again to Matouš Koslivý. Thank you for a presentation and also for providing your voice for the music experiment. That was very useful. So thank you for that. And again, you will have a chance to ask questions either in the coffee break maybe or later in the discussion. But now the final speaker, last but not least, Mr. Joachim Hercher, who is the economic advisor at the representation of the European Commission in the Czech Republic. He focuses on areas of public administration, digitalization, social education policy, and he will be talking about legislative anchoring of AI in Europe, whether it's an inspiration for the world. So please welcome to the stage. Thank you.
Thank you very much. Hello, everyone. It's a big honor to be here, and thank you for your attention. Let me speak about the AI-relevant legislation in the European Union. My experience, or right now my position is here at the representation of the European Commission in Czechia, which is an embassy of sorts of the European Commission. Before that, I worked in Brussels, mainly in the area of data, of public procurement data, so the purchases of governments and how to make sure that is spent efficiently. And in between, I worked at the Czech tech company Seznam, actually, as a product manager in the search engine department. So, the main thing I'll be speaking about today is the AI Act, which I think you might have heard of. It is currently being finalized, so be aware that everything I say is kind of still preliminary. As all EU legislation, it doesn't come up just from Brussels, but from Brussels actually means it being discussed by ministers of individual countries, including Czech ministers in the Council of the European Union, by the European Parliament, and by the European Commission in so-called trialogues, which should finish by the end of this year, but there have been, I think, several thousand comments in the European Parliament actually, so it might take longer. And then I will also briefly mention the Data Governance Act and the Data Act, which are two pieces of legislation about data, which is crucial for AI, so I'll just say a bit about them. I will not mention the Digital Markets Acts, Digital Services Acts, the Product Liability Directive, the regulation about identification of citizens in the EU, the GDPR, and the wide variety of other digital-related legislation that's happening. All right, about the AI Act, essentially it's a response to the threats that AI poses, let's say, or puts on the table. The biggest threat of AI is that we don't use AI enough, and we start using it too late. We speak often in Czechia about Czech salaries not being the same as German salaries, which is a question of productivity of labor at the end of the day and the tools that we use. And AI is a powerful tool for increasing the productivity of people in a wide range of professions, as you've seen today. At the same time, we're aware that we are not adopting AI as quickly as, for example, China or the United States, not mentioning how much we're falling behind, for example, in research, where China many years ago has said they want to be the leading country in AI research by 2030, and in practice they have been publishing the most patents in the area of AI since 2017. So the biggest threat of AI is that we don't adopt it and don't find the use cases where it actually helps solve our problems. When we're talking about AI, we're of course talking about a wide variety of instruments, from very kind of everyday basic things such as translation or voice-to-text transcription, to systems that partially communicate with people like chatbots, to advanced data analysis, or to assistants which should actually be giving tips or could be giving tips in the future to doctors, lawyers, and other expert professions. There's an extreme variety of these tools, and the trick for all of us essentially is finding where they help us. Now, the other set of threats, they are sometimes spoken of in the context of fundamental values, but personally I like framing them more as really practical issues to deal with. Is bias, most of all, so getting results essentially from the AI that are not the best possible ones. To give a trivial example, we probably all know that in the criminal justice system, women get lower sentences for the same types of crime or delicts than men do, and at the same time, for example, ethnic minorities get harder, harsher sentences. So if we use such data to train a system which is supposed to propose things to judges or lawyers, we will get biased results. This is not a particular horrible issue in the sense that it would be specific to the AI. It just reflects the bias which we have in the human decision making on the basis of which we've trained the data. But first of all, we're replicating problems we have, and second of all, we can make them much more at scale, because the AI as a digital tool has a much bigger scale than any of us does as an individual. So we want to be dealing with bias. And then there's the question of transparency and explainability. We need to be able to identify bias. We need to understand how the system works, because the problems can arise from the data, but they can also arise from how the algorithms work, what kind of things they concentrate on, what weights they put to them, and so forth. And we want to be able to explain, for example, what recommendations an AI system was giving to a judge so that the judge can work with it properly, or a doctor. So the story of the AI Act is trying to balance out these two effects. It is an act which is standing on the shoulders of several years of discussions with the public. An interesting thing about the EU lawmaking is that every act gets consulted with the public, with the industry, and so forth, every single one, which, for example, in Czechia is regrettably not the case. And the result of this is essentially a risk-based approach. So there's no one-size-fits-all solution, but there's a classification of AI systems, and depending on how risky they are, there are also sets of obligations that their users, implementers, owners should follow. Again, this is all still preliminary. It can change our discussions about the size of company, for example, being important in the classification of the AI system. There are discussions about whether they should be self-evaluated by their owners or whether it's an external body, and so forth. But the basic idea stays. That means we have a risk-based system. The first category are unacceptable risks. There are two main examples there. One are the social scoring systems, which we've heard of from China, where you essentially get points for being good citizens. And there we say this is not a kind of approach to society which is in line with EU values. The second category is the real-time biometric identification of people. So when you see in movies, camera recording, and right away what pops up is the identity of every person on the camera, and you can end up tracking people as movement even better than now, let's say. So that's also not acceptable unless some conditions are met, such as the court approving such use. Real-time is also an important part of it, or real-time, in the sense that doing this on recorded data is a different category. Now, the most interesting category are the high-risk systems, which are considered high-risk either because they are part of some medical tools or other tools regulated by other EU legislation, or because they fall into sensitive areas such as education or employment or security or justice. And then you have a list of obligations to comply with, and I'll get to that in a while. Then there's a bit of a special category where, for example, generative AI falls into, so ChatGPT. And there are three obligations for these types of systems. First of all, you have to always clearly communicate that some kind of a picture or a text came from a generative AI system. Second of all, there have to be safeguards for the systems not to provide sensitive information, sensitive in the sense of how to make a Molotov cocktail or something. You shouldn't get a picture from DALL-E showing you how to do that, or an instruction from ChatGPT. And finally, there should be a record on how these systems work with licensed information. So if you are Game of Thrones fans, then maybe you've noticed that ChatGPT finished all of the Game of Thrones books faster than their real author, based on internet sources and all kind of Wikipedia summaries of the story. So these kind of borderline cases need transparency on where the data and information about licensed information is actually coming. And the fourth category, which is where the overwhelming overwhelming majority of systems will actually fall, especially in all their business uses, is minimal or no risk, where there are essentially no obligations. The high-risk systems have to be part of regulated products, or this is the full list of the sectors where you have to be using your AI system to be considered high risk. And then these are the types of requirements, not all, and I'm mixing a bit the requirements on the systems versus the operators of the systems, but just for illustration, the main thing is you have to be thinking about the risks and trying to solve them. That's a mindset point. Using high quality training data, testing data, having procedures on how to deal with issues, documenting and logging. That's crucial for the explainability point I mentioned in the beginning. Obligations to inform users on what your system can do and cannot do, whether it's hallucinating, how trustworthy the data coming from it actually is, or the information. Having a human overseeing the algorithm, not having a purely black box where no one knows what's happening inside. And then there is an obligation to register standalone systems and to report incidents, similarly as, for example, in cybersecurity. Next steps, somebody want to take a picture of the slide? Next steps. So there should be the agreement by the end of the year, hopefully. Then there will be 2 to 3 years for adoption of the actual act. There will be some kind of support to help companies adopt sooner, because 2-3 years in AI is truly an eternity, with big news coming in every week essentially nowadays. And in parallel, standards will be developed by SENS and ELEC, which are the standardization bodies at the European level, to support the implementation of these tools. I think that's all for the AI Act, and a few words on the Data Governance Act, which is the one which has been already adopted. It has essentially 4 pillars on data. You might know there's an Open Data Directive currently, which obliges EU countries to publish essentially as much data as they can, starting with high priority data sets for reuse. And the Data Governance Act kind of complements this with an obligation to publish also data where it's more complicated, in the sense that if I have data about companies, that as an individual, pieces of data might be protected for trade reasons or for security reasons, but there still might be ways for me to anonymize it, pseudonymize it, aggregate it, and publish that. Same things might happen to a certain extent for data about individuals. So that is one of the provisions, or what the Data Governance Act brings. Second of all, it establishes a new function called data intermediaries. The idea is there to improve the functioning of the data market across the EU. You might know that the kind of fundamental element of the European Union are the 4 freedoms. That means the free movement of people across borders, of goods, of services, and of capital. And sometimes we speak about a 5th freedom, which is data. So the aim of this is to improve the free movement of data across borders so they can create the wealth and productivity benefits we spoke about. The basic idea of data intermediaries is to decouple those who produce data and those who use data, and have truly independent actors which take care the data is well managed, standardized, and then resold to others in the economy who can do productive things with it. There is regulation on data altruism. Many of you probably wear smart watches which collect plenty of information about you. This information can be useful for medical research, for example, but there was a lack of regulation on who can share with this data, who has the right to work with it, and so forth. So there's an institute of data altruism, and there's a registry, again, of data intermediaries and data altruistic organizations, so that it can be checked whether individual rights are respected. And finally, there's a body to be helping with standardization and exchanges of good practices. Finally, there's the Data Act. I think the naming is not ideal, but as in the Data Governance Data Act, it's not, I think, 100% clear from the names what is their scope. But for Data Act, it's mainly industrial and private data. It clarifies what are the rights around the Internet of Things data, so things generated by your home appliances or your cars or exactly your smartwatches. One of the elements is dealing with contractual unfairness. So in the current wording, it actually says that certain types of contractual provisions between the creators of these devices and other bodies will not be valid. Examples are when the creators of the devices say that they bear no responsibility for anything that goes wrong or mistakes in the data. Second would be if they totally exclude anyone except themselves in using the data coming from these devices, and a few other cases. There are provisions on how the state can request data from private actors in case, again, of a COVID pandemic or some kind of urgency, or when it's needed for public service provision and there's absolutely no alternative. And finally, there are standardizations and interoperability provisions to make sure you can more easily switch between providers, which is maybe better explainable this way, where we have a bit of a complicated slide, I apologize, but essentially three actors: the users, the manufacturer of a device, your smart fridge, for example, and a third party, which could be using the data. Currently, one problem is that if you are easily locked in, I guess fridge is maybe not the best example, which might remember what you want to buy, but I don't know, Spotify and your favorite songs, it will not be easy to export this data to another provider. And so that's one of the things that should change with the Data Act, that you can actually port your data from one provider to another. Second is that when the one who provided you the device wants to share the data with a third party for analysis or enrichment or joining data together. Currently, there are legal unclarities and there are also data standard issues, so that should be resolved. And finally, right now, if I want to send my fridge data to, I don't know, an energy company or something like that, it might often not be possible, while with the Data Act, that should be possible. And the overarching idea is always the same, making sure the data flows under clear conditions, which are just linked to people's rights and money, so that the benefit that the society, the people, the companies can have from this data is as big as possible, instead of ending up in a situation where some actors lock in the data or have a disproportionate power on the market. I think that's it from me. If there's kind of one thing that I would really like you to take away as the main point, I think it's the principle of the Data Act balancing out the need to adopt AI and the threats it poses in as good a way as possible, and doing this through the risk-based approach, or a different approach to different AI systems, and that we have several pieces of legislation already in force and upcoming which are trying to make the data economy work better. Thanks a lot.
Thank you very much to Joachim Hercher, and we are perfectly on time, so we are now concluding the speeches at 12. We will take another quick coffee break, so let's say in 12:20 maybe try to be here so that we can start on time, because we have to finish at 1. Again, then you will have also the room to ask your own questions, and we will also be talking a little bit about the regulation. Okay, welcome back everyone. Hope you enjoyed the coffee break. We are now approaching the final part of today's conference. That is the short but hopefully productive and interesting discussion. I think we have a lot of interesting speakers that we heard today. So Mr. Tilman Becker, Judith Knoblach, Jan Macek, Matouš Kostlivý, and Joachim Hercher again. And I would like to kick off with one question that is, I think it would probably be enough to have a whole conference on it, but try to give a short answer. We heard about the EU regulation of AI. So in general, from your perspective, do you think this will be beneficial and an advantage for the EU or for EU AI business to have a kind of regulation, or can it be a burden maybe in terms of obligations that new businesses need to fulfill, all the administrative procedures? And so what are your views on that? Is that kind of regulation necessary? Maybe you can start at the far end and work towards me, and then we'll open the space for your questions. Thank you.
Yeah, so I think this is definitely interesting and important question. People are, of course, kind of scared from the AI now because they kind of hear the news and the spin is not always positive. So it kind of brings the need in the public to see the regulation happening. But there's the but from my perspective as a kind of AI entrepreneur or AI kind of company co-owner, that it and of a small company, that's important to say, that it can bring burden that may be kind of impossible for us to carry, and it's important to kind of manage the regulation in a way that brings the benefits and limits the risk, obviously. And we were involved in the kind of comments to the proposal of AI Act, and were quite active in the Czech scene, providing the feedback to the European Commission. So yeah, there is this feedback loop, and we were able to comment, but we will see what will be the final outcome and how will it impact us.
Okay, thank you. Yeah, thanks. Yeah, Mr. Herk, do you want to add anything from your perspective?
I think my position is clear, I think, yeah. I mean, the balancing act is crucial. Of course, I hope we manage to get it right. One thing I did not mention was that there are also block exceptions for some areas, like research and development, use of AI, where there would be no requirements. And also one level is kind of the objective regulation. Maybe another level is dealing with the emotions. You said we were talking about the spin for AI, and of course the spin is sometimes negative, and having regulation, even if very soft, may be a good way to also manage these emotions and the fears, and kind of assure the population that we will have the benefits and not the dangers.
Okay, I would say regulations must make sense by themselves. So if they're viewed from the European perspective and make sense for European companies, by all means, yes, they're beneficial, even if they're conflicting with international regulations. And I think the European market is still big enough that it's interesting for almost anyone who's providing services and products internationally to follow the European standards. And if we're leading there, we'll see that most of these standards the others will simply follow, and then it's an advantage to have these leading regulations here, and will actually bring these producers of services and products to Europe to work with the European regulations from day one. We're big enough to be more daring there.
Yeah, thank you. Yeah,
yeah, I wouldn't call it regulations, rather guidelines, and yeah, with that it can be from a user perspective quite supportive for a different type of people. So for people who are afraid of being replaced with AI, or also for people who think AI will solve everything for them and critical thinking is no longer necessary. Yeah.
And yeah, from the point of view of Czech Invest, I would say it can be tricky, because simply if we try to attract foreign direct investment, foreign companies to come to the Czech Republic, to start their research and development activities in the Czech Republic, that's the high added value and stuff that is then brought to economy through that. I can imagine that if a company is about to decide whether to do these activities in Europe or elsewhere where the regulation is not, it can be one of those factors that can play a role in their decision making. At the same time, when we talk about startup support in the Czech Republic and startup support in Europe as such, obviously we would like European startups to grow. We would like the European startups to become the next big thing, to catch up with the US, for example, simply because Europe is very strong in research, but it's not that strong in commercialization of this research. That's happening in the US, as well as a lot of researchers from Europe flee the US companies then that make the profit out of the European research. That's simply the facts that we are facing right now. But I as well well, and this can be all affected by the regulation if not set up right. At the same time, we are at the phase when we can see how artificial intelligence can really help with the utilization of data, with the interpretation of data. We could see what it could do to marketing, how it could target the marketing way more effectively, be way more efficient than it used to be before. We could as well clearly see how it can lock you up in some social bubbles, how it can affect the general public opinions, how it can affect the elections, and therefore become a threat to some extent. And even though I'm techno-optimist, and I believe that AI is really about to bring big positive changes to the companies and society in the future, I can as well see those threats, and these are pretty much the reason why some regulation to some extent would make sense, but it needs to be applied in a very sensitive way in order not to damage the potential of Europe to leverage on these technologies as such.
Okay. So thank you everyone for your quick and short answers. I think we can go, I mean, we heard so many presentations on different topics, we could go anywhere in this discussion, but ultimately I think it's most important to ask you what most interests you. So please, I promised you room for your questions, so now is the time. If you will, you can put your hands up and I will get you the mic.
So I have a series of questions but I'll just start with the medical one. So what are the implications of using AI in medical research and clinical trials?
Yeah, I guess it can be, really supportive in supporting in the field of diagnosis, and I think it's also in the beginning, we are doing basic research about it, and also with this explainable methods we are applying, it will be really good for the patients also, that they can trust the decisions. Yeah, I guess in future it will have a great impact and can be super useful, yeah.
And are there maybe any ethical implications or considerations that you can see now are already important at this point, or?
Yeah, of course. It's we need a medical expert. We shouldn't completely trust the system, and So I guess this is really important to have the human in the loop. Yeah.
If anyone wants to add anything, feel free, but yeah.
Yeah, I would like to say that it was mentioned here, at the beginning AI can be a great kind of help, and it can be this copilot to the medical staff, for example, when looking for some diseases or some screening of some patients' data in order to help them with the diagnosis, simply because right now, if it's very dependent on the skills of the doctor, of course, these skills can vary, and therefore, in regions where, for example, you may not have the medical facilities at this standard, it could really help with to leverage on AI and bring better services to people. I can imagine that it's very tricky because of certifications. You can't simply. It is a bit longer process, and it's a bit more complex than to push just some random marketing app on Android phone. You just need to really have everything certified. It is costly. It takes time. It is not that easy to step in as a startup is, for example, in this field. You need to have some background knowledge, but the utilization in medical aspects is huge. It can bring a big kind of effectiveness to that, and it can really save lives in the longer term. So I'm really looking forward for all those AI applications and medical applications, simply because it can help to save a lot of lives.
Are there any current AI application right now in medicine?
We are doing the research. So, but we don't. Yeah, no. There's. So I don't know. But maybe.
Yeah. One of the examples, for example, again, 2 days ago there were AI awards. One of the awards was given to Carebot, which is a Czech startup. And Carebot, what they do, they do from those röntgens and screenings of a chest, and they look for those how is it called in English? Those cancer kind of tumors, yeah. They help to diagnose tumors to doctors. Pretty much from the screening of these pictures, if you are a doctor, and you need to have skills, you need to have know-how, and you need to know what you are looking for. So at the moment they are working with real-life doctors to annotate the data, to annotate those screenings, and pretty much they are about to bring this tool to the doctors that will help them with the diagnosis, with screening. So even that what would otherwise become overlooked perhaps by some doctors can now be found. What's interesting as well in this aspect, that as they are working with tens and dozens of doctors throughout the Czech Republic, sometimes the same screening and when looked twice by the same doctor can have different results. So even the human error can be eliminated in these crucial aspects, such as screening for tumors. So this is just one of the examples how it can be used. I can imagine that in a way more complex situations, such as when you are looking for some genetic kind of utilization, AI can play a big role as well. Where it can play a big role is as well for companies, those big pharmaceutical companies, when they want to look for some interesting facts in their prescriptions, for example, how medicines can be, for medicaments can be combined or otherwise shouldn't be combined at all. They can find some data that wouldn't be found otherwise. So it can help them pretty much as well this way to look for potential similarities in medicaments, and pretty much even help with the drug discoveries and such. So this is just some of the examples where AI can play a role, and we can see it already today, and a lot of startups are working on that.
Thank you. Hi. So I would like to address this question to basically for all of you, and it's come from all the presentations, what I've seen today. And I fully agree with the approach that, especially in Europe, we need to push the gas as much as we can and start to utilize it and do the research, and also try to bring the research from the lab to the production and start to monetize this knowledge better than than maybe the Asian markets or in the US. And in the same time, we're talking about the AI ethics and the regulation. And the question is that how we're trying to not to fall into that trap, that we're trying to push the gas and the brake in the same time, and being competitive with the other other regions where maybe it's less regulated.
Okay, thank you very much. So that's the question of the regulation again. Like, to what extent? How do you balance it? You know, how can you accelerate it when maybe other parts of the world, they don't really regulate AI? So how do we compete with that? Yeah, maybe Mr. Helke.
If I can start, the trick is really having soft, gentle regulation, which differentiates between the different modes, which is exactly the direction this act is going. And I hope that after the final negotiations, this stays that way. That it's just, you can have regulation which is not blocking, which is not limiting. And this was part of the discussion since the beginning, and it's one of the main concerns of everyone involved. So I'm quite confident that it will end up that way. And in this context, it's maybe worth mentioning there are also AI regulations, of course, both in China and now, I think since Monday, at least through an executive order in the US as well. So there's also legislation happening in some sorts and forms in other jurisdictions. I would say that the EU or AI Act has been discussed for the longest and the most transparently, which might actually be an advantage.
I think that there are still plenty of use cases and plenty of benefits that you can say they are coming from AI, but do not fall necessarily under the AI regulation, because like the scope or like the field of applicability of AI is so wide that it's maybe more about like defining the practical use cases or business cases and getting the business kind of understanding and getting the company, I don't know, running and getting customers and validating it in the market. So there are like so many steps that need to happen for the AI innovation to bring benefit and then bring the kind of money from the market that the regulation. I mean, there are still very many ways how to get the benefit without kind of being or without feeling limited by the regulation.
Yeah, and just a bit more of a context again, because the AI Act and all these regulations that we are talking about, they are about to come in place in about 3-4 years. I don't know when exactly. So we know that AI can be the next big thing that can really bring those societal changes and can perhaps do as well some harm if not treated properly. So this is what this is about. But at the same time, we are in the environment of artificial intelligence that within last 6 months, 8 months changed rapidly, and pretty much 1 year ago people would not really be thinking about artificial intelligence as they are thinking about it now, simply because suddenly those generative AI models, they suddenly show to the broader public how it can be used, how it can be beneficial to your work, and people start using it, and therefore you can see that even the generic kind of opinion about AI changed within those couple of months rapidly, and it is really difficult, in my opinion, to push some regulation to something that you have to perceive the situation that will be in 3-4 years in this specific area that is changing week by week and in so dramatic way. So really difficult, complex scenario that we are working with, and I can imagine that multiple governments are thinking about how it can benefit them, how it can kind of harm them, and how to put some regulation that is of a benefit but not of a harm. And this is something where we balance a bit. I can imagine the discussions are not really easy, so hopefully in those 3 years we will have some regulation that will make sense and will be benefiting.
Can I just sorry, one more short comment? What Jens said. I mean, another danger of the AI Act might be that we're talking about the AI Act actually that much, because the biggest danger might actually be the business cases and the investment gap and the willingness of our medium and larger businesses, or even the small ones, to actually invest into the adoption of AI. And we talk about that, I think, much less than we do about the regulation.
Where do you think in the next few years, maybe not more, since that's riddled with uncertainty, where the current or maybe new AI technologies will be the most transformative on the technological, economical, cultural layer? Like, where do you see the biggest changes from the status quo right now with the most probability? Probably not like more than 50 years, since that's pure uncertainty, but maybe you have different uncertainty there also.
Okay, thank you. Anyone wants to start?
Yeah, maybe I can start, and it kind of justifies what I was presenting previously, right? So I think there is a quote that this century will be century of biology, but I think it will be a century of AI applications in biology, and I think that's the answer.
Well, I think the biggest challenge that we're facing currently with more and more things being digitalized is have meaningful access to it. There are lots of databases, there are lots of texts all available digitally, but it's very hard to get access to what exactly it is that you want. And AI technology can help to make that access more immediate, to summarize things for you specifically. And that kind of co-pilot assistance technology, that will be driven by AI more and more. And that will really change the way people address problems, because they have all the knowledge actually available to them, not theoretically, but practically. And that will be a big change in all industries and in society.
And then the question of bias becomes crucial, right?
Absolutely, and the validity of information. If you have access to something that's provided to you by a system that you get for free from Meta, but doesn't exactly tell you what's true, then you have a big problem, yeah.
Yeah, so we had biology, access to information, and the other bets.
we could see now how big change can bring, for example, one part of application in AI. For example, now the generative AI is talked about a lot, and it brought the biggest disruption to a lot of industries, to how they operate, what they do, how they do it, from legal to other applications, including one that people expected that will come the last, which is the creative kind of aspect. People thought that that was something that I thought was that AI will come to replace creativity, human creativity, at the very, very last instance. But we could see now that we can generate pictures, we can generate music, we can really utilize it in this creative way. It can be a tool for somebody who can utilize it. It can be big thing because it can really help him to create something that wasn't possible before. Or you need huge resources. Now you can make a film about something in your living room, something that you used before huge budgets for, and it was not possible to make it as an individual. So it's what AI does is actually that it brings those opportunities to a lot of people that were not here before. And I always think about it when I see, for example, myself when I was studying, and I remember that when I wanted to know something, I had to go to my smarter classmates, and they would kind of give me advice how to do the math or stuff. And now I can see that that people have other options, and they are like in an instant. You can look on YouTube. That was the first kind of help that you could do. That's something I do when I need to repair something. I wouldn't be able otherwise. I mean, like now I was able to repair my phone when something broke, and I had no clue how. And then suddenly I was dismantling it, and it works. So this is something which, in my opinion, AI will bring in the future. So it's as well about the aspect, and this is something which is as well crucial. How it will kind of be seen within the educational system of the Czech Republic. It's developing so fast that it's really hard to implement it properly. And there are other aspects such as AI Dětem, for example, or other initiatives of that kind. That AI Dětem is a Czech platform that tries to change how AI is taught in elementary schools. So these initiatives that are not really run by governments, but by general public, by somebody who really knows what should be done and then pushes it forward. These are as well initiatives that are worth studying, looking at, and I can imagine that in the longer aspect we will need as well to reevaluate how we are teaching stuff at the school, because now kids have absolutely different kind of opportunities to what we had when I was a kid, and I am not that old. So this is something really that's imminent already here now.
Yeah, thank you. You mentioned also the AI in arts and in the creative sectors, which maybe might be an idea for a future conference, because it's a huge topic as well that comes with a lot of also problematic aspects, because a lot of artists, if you talk to them, are maybe not without reason afraid of being replaced over time with AI, you know. So this is also something that's worth discussing in the future. So not today, but maybe Judith Knobloch, if you want to add any. We heard a few examples of like when you look further into the future of uses, or where you see perspective for AI, what would you highlight?
Yeah, I cannot say a concrete field, but yeah, I think all the processes which are easy to automate and where we have big data, and yeah, there AI can support. Finding information, and yeah, it's also maybe this annoying, time-consuming processes. Yeah.
few points on this. I mean, I think one interesting question is what is actually a big change? In the context of AI, one of the discussions is, there have been, let's say, 2 big changes in the history of humankind, which was the agricultural/Neolithic revolution. We've had the Industrial Revolution, and there hasn't been anything since. If you look at the numbers about the average age, average wealth, and so forth, and the internet, for example, has not had such an impact on human civilization as the Industrial Revolution has. And there are people who say AI will have this impact, and people who don't, and I have no clue because I think forecasting the future is very hard. But the second element is there's something called the Gartner hype cycle, if you know it, which is kind of a nice model of how people react to technology in general. And you have a new technology, it can be AI or blockchain, and everybody is saying, oh, it's going to solve all the problems in the world, it's going to be awesome. And then people are disappointed because it does not solve all the problems in the world. And then they come to the plateau of productivity, and you start finding the use cases, and it incrementally improves things. And this tends to repeat with most technologies. And so again, a question whether AI will be the same case or not. Definitely the majority of added value of AI, I believe, will be incremental. Just many things will get more productive, but it will be little changes. Not sure if it will be like really game-changing. Biology is indeed a brilliant example. Any kind of very complex, multifaceted problems which humans struggle with, that's interesting. AI-powered research, right? AI which reads academic papers and proposes new hypotheses, or even is able to some extent model experiments in the pharmaceutical sector, in the biology, in the medical sector. Sounds very interesting. One element I find as a possible venue would be education also, because if the current state is that the generative AI kind of looks like a person with an average understanding of things, which sometimes makes mistakes. I can imagine the conversations with such people are already beneficial for an 8-year-old, 10-year-old, something like that. So getting to a state where our education is actually individual tutoring of students by AI with the help of multimedia resources, that would be a really life-changing thing, because we all go through the educational system and there are so many things which would be better about our educational system. So that would be one idea or one bet.
Okay, thank you very much. So a lot of future avenues. And we are unfortunately running out of time, so I'm sorry. We will have to take it to the coffee break maybe, because we will still have a final glass of wine that we would like to invite you to. So maybe you can address one of the speakers if you're interested in more details. But that was it. So thank you very much for coming to the audience. Thank you very much for all the speakers that joined us today. Thank you to everyone watching us online.
Thank you.
Thank you to all the organizers, and also thank you to the technical team that was supporting us today. So thank you. Thank you, and see you some other time. Thank you.